Hello guys, welcome back to this channel. For today's video, we'll discuss about alcohol. And alcohol will have 4 subtopics. The first one, 5.1 IUPAC naming. Second, you have your 5.2 physical properties. And then you have your preparation of alcohol. Last but not least, you have the chemical property of alcohol. For this video, we'll look into your IUPAC naming. So, what is the objective in IUPAC naming? There are only 2 objectives, or pretty much 3 objectives. The first and second objective is to be able to draw and name the alcohol. So, we'll be using the IUPAC rules that you have learned in your alkane and alkene. That will be very similar, only very small, slight difference. Next, we will be also looking for the classification of alcohol. How do we classify primary, secondary, and also tertiary alcohol? Simple. Let's start with asking what is actually alcohol first. Alcohol compound must have at least 1 hydroxyl group. You must have at least 1 OH group in your compound, then only we will call that as your alcohol. And the general formula for the open chain aliphatic alcohol will be CN H2N plus 1 OH. So that is the alcohol group that we are looking for. Or we can write it as CN H2N plus 2 with a O. Both are actually the same. Can you look at it? Alright, that is the H that we plus 2 just now. And this is the general formula of an aliphatic alcohol with at least 1 OH group. Let's look at what makes the IUPAC naming in your alcohol different from your alkane. So, you have your alkane, you have your alcohol over here. Let's look at the changes of the parent name. Your alkane will have your methane 1 carbon A and E. That is your 1 carbon methane CH4. And what about 1 carbon alcohol? Your 1 carbon alcohol will be named as methanol. And if you look at methanol, the spelling difference is only your OL and also your E over here. So your E in the methane, the last E in the methane will be replaced by OL, then the name will become methanol. So that will become your alcohol 1 carbon, where the formula will be CH3OH, 1 carbon alcohol. So from the alkane to the alcohol, we are simply changing the E at the back of your alkane to the OL at the back of the parent name. So changing the E to OL at the back, therefore your pentane will become pentanol. So your pentane 5 carbon straight chain will become a 5 carbon alcohol with the presence of 1 OH. By simply substituting one of the hydrogen with OH group. Can you see that? So you are changing from E to OL, changing one of the H with OH group. And then you'll be able to get your alcohol. Simple. So the parent name is generally the same, but you're changing the E to OL, so you're changing from methane to methanol, ethane, 2 carbon to ethanol. You can have your propane 3 carbon to propanol. Can you see that? Alright, so you're basically changing the E to OL. Nothing big deal over here. Simple. And that is the alcohol name. There are only 2 golden thumb rules for your IUPAC naming of alcohol. The first golden thumb rule is the longest parent chain must have the OH group in the longest parent chain. So simple, like your alkene, the carbon-carbon double bond must be in the longest parent chain. So same thing over here, your OH group must be in your parent chain. And the second golden thumb rule in your IUPAC naming is the OH group, the carbon that holding the OH group, must be at the lowest possible number. So all the parent deserve to get the lowest number, like your carbon-carbon double bond, but over here we are changing to alcohol. So the carbon holding the OH group must be at the lowest position. Let's look at some example. I have my 5 carbon chain over here. So my OH is located on the carbon left hand side number 1. So what would be the name of this? This guy will be your pentanol. And it's not needed to put 1 in front because it's located at number 1. And you'll be counting from the left for this question. The second example that we have is still a 5 carbon, guys. It's still a 5 carbon if you look at it. So it's still your pentanol. But your OH is located on which carbon? It's located on the second carbon because I need to count from the left so that the carbon that holding the OH will get a lower number, number 2. But if we are counting from the right, then your carbon that holding OH will be getting number 4. So OH must be at the lowest possible number. Therefore, you have 2 pentanol. Look at the way that I write my name compared to the first one. So you have a position in front of your parent because your OH can be changing position. So you must mention your OH right now is located on which carbon. I'm still having my 5 carbon straight chain and my OH right now located on which carbon. You realize that in this case, counting from the left or counting from the right will give rise to the same number. So you can always pick anyone in this case. So the name will be 3 pentanol. Why 3 pentanol? Because your OH right now is located at carbon number 3. So the position of OH is very important in the parent name. You must give a position to the OH. Unless it's located at carbon number 1, then it's not needed to put the 1 pentanol. Okay? Simple. So let's look at some example over here. And how do we start? We need to identify where is your OH first. After you identify the OH, we will start from the carbon that holding the OH. Okay? And then moving from the carbon to the top, to the left, or to the right until you come across the last carbon. So for this one, the last carbon when you're moving across will be on your right hand side, this one. And then another road, another side will be going up and then turning. Okay, and still not your last carbon. Your last carbon is all the way up here. So we will always start with the carbon that holding the OH group. That is the easiest way to find the longest carbon chain. And then we count how many carbon we have. 1, 2, 3, 4, 5, 6. That will be your hexanol. So your hexanol over here is how many hexanol? Your OH, counting from the top will give you the lower number, or counting from the bottom will give you a lower number. Obviously, counting from the bottom because I will have 1, 2, 3, 4, 5, 6. So the carbon that holding the OH will be at carbon number 3 and that will be your 3 hexanol. We want the lowest possible number of your OH group. Simple? Easy. And before we move on to more examples, I want to remind you the IUPAC rules that you have learned previously all will be the same. For example, the name of your substituent will be the same. Your methyl group, your ethyl group, your isopropyl, sec-butyl, all that will be the same. Every substituent also deserves a position. Don't forget the position of your substituent. When you write their name completely, you need to arrange them in alphabetically order. The prefixes di, tri, tetra for the same substituent. Alright, all the rules that you have learned previously basically apply in your alcohol, except your alcohol right now having the word OL and the OH group must deserve the lowest position. Comma in between numbers, alright, all the standard thing guys. Dashes between the numbers and alphabet. All that is the standard IUPAC naming rules that we have been learning. So all these will apply as well in the naming of alcohol. Let's try another example. So as always, we always start with the carbon that holding the OH group, choosing the direction that gives rise to a longer carbon chain. So over here, left and right, obviously right. So that is the direction that I will have more carbon. And then left and top, of course going to the top because I have more carbon. And then move until you become the last carbon. Alright? So over here, moving to the top or moving to the right is actually the same, up to you. Because they give rise to the same number of carbon. And as always, this carbon deserves to have the lowest possible number because of this OH group. So the OH group and the carbon must deserve to have the lowest number. I have a 6 carbon again, guys. 1 will definitely from the top so that the carbon that holding the OH can be carbon number 3. The lower number, 4, 5, 6. So the parent over here will be your 3-hexanol. You have 2 substituents. The first substituent that you have is your 2-methyl group. The second substituent that you have is your 3-methyl. So the same thing as you learned previously. When you have the same substituent, what do? We combine them with the prefixes of di. So the complete name of this organic compound alcohol will be 2,3-dimethyl. Because you have 2 methyl groups, so you need a 2 position. And then your parent will be 3-hexanol. And that is how we get the name of your alcohol over here. Simple, easy. Let's look at another example. Same thing. We will start with identify the carbon that holding the OH group. So this is the carbon that holding the OH group. We are going to the left, going to the top, or going to the right. Always choose the one that gives you longer carbon first. I will choose to go to the right first because that gives rise to more carbon. And then we need to move until you become the last carbon. You can go straight to the right or you can go down. Of course, going down because you have more carbon. Go to the direction that gives you the longest carbon chain. And then over here, you can go to the left or you can go to the top, and both will give rise to the same number of carbon. So choose anyone you wish. They are the same in this case. And the position will depend on the carbon that holding the OH. This carbon deserves the lowest number first. So counting from the left or counting from the right. If you look at it, obviously counting from the left, so that I will have a lower number 3 over here. And then, so your parent over here is a 7 carbon, therefore your parent will be 3-heptanol. Heptanol because it's a 7 carbon, 3 because your OH located at carbon number 3. We have 2 substituents. The first substituent is your methyl group 1 carbon, that located at carbon number 5. So you have your 5-methyl. And then you have another substituent over here. The second substituent you have is your ethyl group 2 carbon that located on the 3rd carbon. So you have 3-ethyl. And the full name of this organic compound will be alphabetically ordered. So 3-ethyl, 5-methyl, 3-heptanol. And that is your IUPAC naming. Simple, easy. Let's try one more last one. That is my OH group. Identify your OH group. Identify the carbon that holding the OH group. And this one, you can only go to the top or go to the right. So obviously going to the right is a must even though it's only 1 carbon because that is the N already. Going to the top over here, guys, always go for the longest parent chain. So moving to the left because it has more carbon over here. And right now, moving to the left again or moving to the top. It's actually the same, but moving to the top will give rise to more substituent. So we will choose the one that gives rise to more substituent. So your parent over here is how many carbon? Your parent over here is 1, 2, 3, 4, 6, 7. Again, your parent over here is your 2-heptanol. Again, is your 7 carbon. Why I start counting from the bottom straight away? Because my carbon that holding the OH group must deserve the lowest number 2. Okay? Always remember, your longest parent chain must have the OH group. Therefore, you start from the carbon that holding the OH group. Second, the carbon that holding the OH group must have the lowest number. So we will always count from the direction where the OH group have the lowest number. Simple. Let's see how many substituents you have. The first one that you have over here is your methyl group that located at carbon number 3. Another one, you have another methyl group that located at carbon number 6. Last but not least, Your another substituent over here is your ethyl group that located at carbon number 5. And your IUPAC naming will depend on the substituent alphabetically order. So the alphabetically order is the ethyl come first. Therefore, the complete name will be your 5-ethyl, 3,6-dimethyl because of the 2 same substituent, and the parent will be 2-heptanol. And that is the complete name of your alcohol above. Simple, easy. Alright? Everything is actually remain the same except the parent. The parent is changing the E to OL, and you need a position, the lowest position for your alcohol. And that's it. And that is the only difference for the naming in alcohol. Let's see the drawing when the name is given. So when the name is given, the drawing always start with the parent. We always start with the parent, and the parent is a hexanol. Hexanol means 6 carbon. So we will draw the 6 carbon straight chain first. And then simply indicate the position. That is my carbon number 1, 2, 3, 4, 5, 6. And then it's a 2-hexanol. So your OH will be located at carbon number 2. And then fulfill all your substituent. Do not put in the hydrogen. Hydrogen is the last thing that you put in to complete the 4 bond of each carbon. So put in your substituent first. We have 3 ethyl group. 1, 2, 3. Your carbon number 3 holding 3 ethyl group. 4,5-dimethyl. So your carbon number 4 holding a CH3. Your carbon number 5 holding a CH3. And then you are done with this, you are done with this. Then only you complete each of the carbon with enough hydrogen. So the carbon number 1 will have another 3 hydrogen to make it a 4 bond carbon. The carbon number 2 will have 1 more hydrogen. Carbon number 3, 1 more hydrogen. Carbon number 4, 1 more hydrogen. Carbon number 5, 1 more. Carbon number 6, 3 more hydrogen to make it a complete 4 bond. So that is how we start drawing your alcohol. Always start with the parent. And then give position to the parent. And you put everything in first except hydrogen. Hydrogen is the last thing that you put in. Okay? Alright, let's look at another example. You have your 1-bromo, 4-isopropyl, 2,6,7-trimethyl, 3-octanol. So always start with the parent, 3-octanol. And the octanol over here represent 8 carbon. So put down the 8 carbon. And then straight away put down the position for each of the carbon. And in this case, you can count from the left or the right. It doesn't matter because we are the one that giving the position to your parent. And then it's a 3-octanol. Therefore, your OH must be located at carbon number 3. Put down each and every of your substituent. You have your 1-bromo. So carbon number 1 holding a Br. So carbon number 4 will be holding the isopropyl CH, CH3, CH3. That is your isopropyl. And then you have your 2,6,7-trimethyl. So 2, 6, 7, trimethyl. And are you done? No, you are not done yet. You are only done with the name of the parent and each of the substituent that you have. But the carbon having not enough bond yet. So make sure every carbon that you have on the screen right now have 4 bond. Those that doesn't have enough, you will put in more hydrogen. So complete each of the carbon with 4 bond. And those that have not enough, you will put in hydrogen. And that is how we get the complete drawing of your organic compound. That is how we draw it. Okay? Simple. Easy. And always remember, hydrogen is the last thing that you put in to complete the 4 bond of each carbon. Next, let's move to classification of alcohol. We can classify alcohol into 4 groups. Your methyl alcohol, your primary alcohol, your secondary alcohol, your tertiary alcohol. So your methyl alcohol is only your methanol holding your CH3OH. That is your methyl alcohol, where the carbon is not bonded to any carbon. That is your methyl alcohol. So how do we classify your primary, secondary, and tertiary alcohol? Simple. Let's see. The class of the alcohol will be 100% depends on the class of the carbon that holding the OH group. So if the carbon that holding the alcohol is a primary carbon, then it will become a primary alcohol. If the carbon that holding the OH group is a tertiary carbon, then it will become a tertiary alcohol. So it's very simple. It's actually the classification of your carbon, but we only look at the carbon that holding the OH group. Okay? Simple. Let's move to the example straight away. So the first example that I have over here is your butanol. So looking at your butanol, we only focus on the carbon that holding the OH group. Okay? Looking at this carbon, we know that this carbon is a primary carbon because it only attached to one carbon. Therefore, this guy automatically primary alcohol. Simple. Easy. Next, looking at the carbon holding the OH group only. We only focus on the carbon that holding the OH group. And this carbon that holding the OH group right now is a secondary carbon because this carbon is bonded to two more carbon. Therefore, it will be secondary alcohol. So the class of the alcohol will depend on the class of the carbon that holding the OH group. Another example. Again, we look for the carbon that holding the OH group only. This is the carbon that holding the OH group. And we only look at this carbon, the carbon that holding the OH group, and classify this carbon. One carbon, two carbon. So this guy is a secondary carbon. Automatically, secondary alcohol. Simple, easy. Okay? More example. So we are looking again at the carbon that holding the OH group. So this is the carbon that holding the OH group. And this carbon right now is a tertiary carbon, holding to one carbon, two carbon, three carbon group. Therefore, this guy will be tertiary alcohol. Another example, it doesn't matter how big is your alcohol group. What matters is which carbon holding the OH group. So this carbon is the one that we need to classify only. And this carbon obviously is a tertiary carbon. Automatically, this one will be your tertiary alcohol. Easy, simple. Last but not least, the carbon that holding the OH group, that is my carbon that holding the OH group. And we focus only on the carbon that hold it. So this carbon right now is a secondary. If you look at it, it's a secondary carbon. Therefore, it will become a secondary alcohol. Simple, easy, and that is the easiest thing in this video. So I hope this video helps you a bit in the naming of alcohol and in the classification of alcohol. Don't forget to hit the like button and also subscribe to my channel for more videos. Thank you for watching and I'll see you in the next video.